Hi there. My name is Devan Hill. I am a senior in the electromechanical engineering program, and my project is called the Addressable LED Electronic Trainer. So the problem statement is that light emitting diodes, or LEDs, are becoming more widely used, and students at Vermont Technical College are starting to learn about and work in labs more with these addressable LEDs. The college is yet to have a system that would allow students to explore these LEDs and make multiple testings. Such a system would need to be made to accommodate at least 3 future labs. An LED trainer system is proposed to be built for the electrical department at Vermont Technical College. A microcontroller would be used to control the array of LED strips and will be powered by multiple power sources, and it will be modular to allow maximum testings. This LED trainer will function as both an infinity mirror and a message board. A couple specifications that I had at the beginning of this project was that it needed to be modular. I needed to design at least 3 labs that will help train future students in working with these LEDs. The 3 labs being an infinity mirror, a message board, and a joystick-controlled LED array. It needs to also have multiple power sources, the first one being a 12-volt 6 amp to power the LED array. The second being 3.3 volt 3 amp to power the microcontroller and the joystick. So the modularity of this system is that by making certain mechanical and electrical components movable or adjustable, the user then gains the ability of making changes and trying new experiments. So like with the LEDs, I can move them from being in the form of an infinity mirror to a message board. The breadboards are easily accessed, so the rewiring can be done. The KL25Z microcontroller is accessible, so the code can be adjusted. The labs, the first one is just a basic infinity mirror. So the LED strips are stretched around the interior of my frame over there. And multiple programs can be performed where the LEDs will light up and change colors in certain orders. The second lab is a message board where the LED strips will be placed in the middle of the board, and the student can type a message in on a keyboard that they would like to see appear. The LEDs will light up in a way that will show that message. And the third lab is a joystick-controlled infinity mirror, where the joystick will control which LEDs turn on and while the rest remain off. The microcontroller, so the system diagram here, the microcontroller over here is powered by the 3.3 volts power supply. The microcontroller then controls the array of LEDs on both the infinity mirror and the message board. It also sends power to the joystick. And the joystick will then control the LEDs through the microcontroller. The 12-volt 6 amp power supply will then power the array of LEDs. So for the first part of the electrical components, the KL25Z microcontroller will control the LEDs for the infinity mirror and the message board. There are 3 wires that go from the LEDs, 2 of which are plugged into the microcontroller. The first one goes to a ground, and the second one goes to a digital output pin. Onto the light emitting diodes. This type of LED is called an addressable LED, meaning the data can be written into a controller and can vary the brightness or the intensity and the color of each LED. There are actually 3 LEDs inside of each one of these little squares here. There's multiple squares per strip. And the colors inside of each of the square is red, blue, and green. Using a combination of these 3 colors, almost any color can be made. Each of these strings that I have here, which are actually black, not white, are about a foot long, meaning that there's about 16 of them per strip. And this means that it runs off of at least 0.96 amps per strip, and at a maximum of 6 strips going at the same time, there can be a maximum of 5.76 amps. So I had 2 choices for the joystick. The first one was a parallax 2-axis joystick. The second one, an Alps 4-direction joystick. Both of them had pros and cons. The Alps was more simple wiring scheme. It also had the ability of a click feature where the joystick could be pushed down in the middle to make a click. Whereas the parallax was a little bit larger, more user-friendly, and the code was simple to write. So I went with the parallax joystick. So I just said the pros of it. It's simple to wire. The code is simple. And a couple of the key specifications was that it had a relatively low power rating at about 0.1 watt. Well, watts meaning that it could be powered by my microcontroller. On to the mechanical design. So the prototype was first designed in a CAD program called SolidWorks. The frame of the trainer is divided into 2 segments. The upper portion here is where the message board and the infinity mirror go. So the LEDs for the infinity mirror will go right down the side, around the bottom, the top, and this other side. The message board, the LED strips will go across the board. And on the bottom segment, down here, is where all the wiring will happen. So the joystick will be in here, the KL25Z microcontroller will be in here, and all the wires will run down the side wire chases here, down into the main box. The next step, I made a model out of this sort of foam board. The purpose of this was to try to find anything that would go wrong with it, anything I could add on, make better with it. And from there, I went on and I cut this ABS plastic to build a prototype, which ended up looking like this here. ABS is an acronym, and I cannot pronounce all 3 words. But the entire box is made out of this ABS material. The materials I used were the foam board for the model frame, the ABS plastic for the prototype frame, ABS cement to hold it all together, and then a couple of hinges and bolts to put the little panel, opening panels on. Onto the program. So there's one program that will carry all 3 labs. The first part right here, each one of these lines is a different LED in each of the strips. So the first one, this little 20 here is the red, the 0 I believe there is the blue, and then this over here is the green, and we'll go red, blue, green, red, blue, green, red, blue, green. It'll vary how much of each color is in one of the little squares, which will be a totally different color. Over here, this is how you turn on each of the different types of patterns here. So each one of these is a different pattern. And so each one of these buttons controls each one of these patterns, which one goes on. And over here, this is for the joystick. Very short, very simple. My budget was right around $91. I know Professor St. Dennis said that I had a budget of whatever, but I think he said around $200 was the maximum he was hoping to spend, so I was under that amount by quite a bit. In my work breakdown structure, I had a total of about 43 hours estimated. In the end, I ended up having right around there at the moment. I'll have quite a few more hours to add in. I think that I underscored myself on how many hours it would take for writing code. Now, looking forward to any questions. Just one. C program. Yep. Yes. Yep, all the strips are interchangeable. They're all the same length of 16 LEDs, and so you can just pop one out, pop the next one back in. Yes,
Is
Professor.
there a reason your microprocessor needs a 3 amp power supply?
Microprocessor,
Doing other things?
it's just controlling the joystick, and I was controlling one set of LEDs to do the testing, so that's why I added it 3 amps in the beginning. Yes.
So when the student removed everything from that box, would something stay in there?
They can take everything out if they wish. It's definitely difficult to, get the breadboards back into place exactly where they were. You can move them. You can take all the wires out. Yeah, that's not the intent of pulling all the little wires out. You can take the KL25Z out and then take out, unplug the wires and rewire it, but you can pretty much leave all of the wires in the chases that they're in. Yes. Yes, there's much more. Yeah.